So we created a background for understanding the first law of motion by understanding contact and non-contact forces and then balanced and unbalanced forces in the previous two videos. Let's look at first law of motion in detail. Let us begin by going through the statement of first law of motion. A body continues to remain in a state of rest or uniform motion in a straight line unless an unbalanced force acts on it. So we are talking of three things over here: rest, uniform motion, and in a straight line. So we are talking of motion of an object, and there are three possibilities: rest, uniform motion, straight line. So the first law says that if a body is at rest, it will continue to be at rest unless an unbalanced force acts on it. If it is in uniform motion, it will continue to be in uniform motion. Under what condition? Unless an unbalanced force acts on it. And if it is moving in a particular direction, if it is moving in a line, straight line, it will continue to move in that same straight line. That means in the same direction, unless an unbalanced force acts on it. Just to clarify, uniform motion means constant velocity. So this is what the first law of motion talks about. On the face of it, it might appear commonsensical, but the first law of motion actually creates a foundation for entire mechanics. All the other laws of mechanics, you can say, in some ways are dependent upon the first law of motion. The two concepts, the concept of inertia and the concept of force, are very closely linked with first law of motion. In fact, in the statement you can see the concept of inertia and the concept of force, which we will be talking about just in a few seconds. So let us take this statement and try to understand the concept of inertia. So what is inertia? Inertia is the inherent property of an object to retain its current state. All objects, they have this inherent property. Inherent means they are born with that. They possess that property naturally of being in the state that they are in. If they are at rest, they will be at rest. If they are in motion, they will continue to be in motion with the same speed and in the same direction. In simple words, objects don't like change. Change in speed, change in direction. They prefer to continue to be in that same state. And this natural property of all objects is called the property of inertia. From an English language perspective, we can call inertia as a reluctance to change. Now, we have talked about three things in the previous slide: rest, motion, and in a straight line. That means here we are referring to direction. And based on these three things, we have three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Let us look at them. Let us study a few examples of inertia of rest. Let's begin by looking at the first example, when a train starts suddenly. So let us say this is the floor of a train. These are the wheels of the train on the railway track. These are the railway tracks. And let's say the passenger is sitting on a chair over here. So these are his feet on the chair and his body, and he's sitting over here on this chair. And the train is at rest. The train is at rest means this floor of the train, this is at rest. And this person sitting is also at rest. Now, if the train starts suddenly, that means this particular floor will start moving in the forward direction. And this particular floor will also try to take the person forward because he is in contact with the train. This person has inertia of rest. Therefore, this person will try to remain in that position. So it is as if this particular floor is going forward and this person is trying to remain over there, and therefore it feels as if the person is falling behind because the person has inertia of rest. So to understand whether it's a case of inertia of rest, what you have to see is that is the object initially at rest? If yes, that's an example of inertia of rest. Here the passenger was initially at rest. That means he possesses inertia of rest. When we study inertia of motion, we will also ask the same question. Is the object initially in motion? If yes, the object is initially in motion, the object will possess inertia of motion. Shaking branches of a tree. So let's say there is a branch of a tree which has some ripened fruits on it. Instead of plucking the fruits, what we can do is we can shake the branch. If you shake the branch, the fruits will fall off because the fruits have a tendency of inertia of rest, or the property of inertia of rest. They want to be in the same position that they are. So when the branch is shaken, the fruit wants to be in the same position, therefore it falls off. Another example is dusting a carpet. So when you're dusting a carpet, you don't remove the dust particles by removing them. You don't pick them up from the carpet. What you do is you take the carpet and hit it against a wall or some object. The particles want to remain in the same state or the same position that they are. So when you hit the carpet, they remain in the same position. The carpet in some sense comes out of those dust particles. I repeat, the particles are in the same position. The carpet comes out of those dust particles. That's an example of inertia of rest. Right, let's take some examples of inertia of motion. When a passenger jumps out of a moving train, some of us try to do that. The train is about to stop on the platform. Before it stops, we jump out of that train. And when we jump out, what we generally do is we run along with the train in the direction of the train for a few meters. The reason is because otherwise we will fall down. When we are in the train, we are in motion. When we jump onto the platform, if we don't continue to be in motion, we will suddenly come to a stop and topple over because we are in a state of motion and we will want to be in a state of motion, whereas the ground, that is the platform, will try to stop us and therefore we might topple over. An athlete runs before taking a long jump because if he tries to jump from a state of rest, he will not be able to cover a long distance because he is in a state of rest. Whereas if he is in a state of motion before he takes the jump, when he takes the jump, he will continue to be in a state of motion and thereby cover a longer distance. A cyclist moving along a level road does not come to rest immediately after he stops pedaling. Inertia of motion. The vehicle is in a motion and it wants to continue to be in a state of motion. The friction force stops it. If friction force would not have been there, the cyclist would have continued moving along that road infinitely or for a very, very long time. The picture over here is another example. You're driving and you suddenly apply brakes. You have a tendency to move forward because you are in a state of motion. That's an example of inertia of motion. One more example of inertia of motion. So let us say this toy truck with all these blocks is going down the inclined plane. Now all these blocks which are there inside the toy truck have inertia of motion because they are in contact with the floor of the truck. The floor is moving forward because the truck is moving forward, and because the floor is moving forward, all these blocks are also moving forward. Therefore, they have inertia of motion. Now, when this truck reaches over here and bangs into this barrier over here, you can see these blocks toppling over, going forward like this. That is because they have inertia of motion. A force has been applied over here and the surface or the floor of the truck is stopping. But these objects, they have inertia of motion, therefore they carry on forward, and those which are on the top, they topple over. And you can also see those which are lying behind, they also come forward because they are in motion and they possess inertia of motion. Let's look at inertia of direction. When traveling in a car, we get thrown to one side when the car takes a sharp turn at highest speed. All of us have experienced that. Sitting in a car, and if the driver takes a turn at a high speed, what happens is that we have a tendency to fall in the opposite direction in which the turn is being taken. That is because the reason is because we are moving in a particular direction. We are moving in a straight direction. So let us say this is the turn. along which the car is moving. So let us say the car is over here and now it is going to take turn. There is a person sitting over here on the right hand side. So when this car is taking a turn like this person has a tendency to go straight because he has inertia of direction. So he wants to travel straight, but the car is taking to the left. Therefore, he falls in this direction because he wants to continue to move straight. And therefore, when the car is taking a turn, he still wants to move straight, and therefore he hits or bangs against the right side if the car is taking a left turn. That is inertia of direction. You must have also experienced inertia of direction when you take a turn and an object which is kept on the dashboard, when you take a turn, moves in the direction opposite to the direction in which you are taking a turn. That is also because that particular object on the dashboard has inertia of direction. It wants to travel straight. One common misconception over here is that we feel that we are moving right, we are moving to the right, or we are moving in the right direction. Actually, we are not. We are going straight. Since the car is taking a turn, we are hitting the right door of the car, and therefore we feel we are moving to the right. Actually, we are moving straight because we have inertia of direction. So we have seen the various types of inertia, inertia of rest, inertia of motion, and inertia of direction, and how it is closely linked to Newton's first law of motion. Newton's first law of motion is also connected to the concept of force. In fact, it helps us understand what is force, because it says that an object at rest or motion in a particular direction will continue to do so unless an unbalanced force is acting on it. So from this we conclude that what is the job of a balanced force? I mean unbalanced force. What is the job of an unbalanced force? To change this. If a body is at rest, let it not be at rest. Apply force and make it start moving. If a body is moving with uniform velocity, change its motion, change its velocity. If a body is moving in a particular direction, an unbalanced force will change its direction. So for this, we get a qualitative idea of what force is. What is force or what is unbalanced force? Now, every time we will not use the word unbalanced force. When we use the term force, it will automatically mean we are referring to unbalanced force. So when a force is applied to an object, it changes one out of these three things: rest, the state of rest or the state of motion, or the state of direction. So we have got now a qualitative idea of what force is. Force does, or force changes one of these things. There's one more role or one more thing that a force does, which is not directly connected to first law of motion, but we should mention it, and that is change shape or size of an object. So a force is something which changes these three things or changes the shape or size of an object. Right. So we have had a close look at first law of motion. We have seen what the statement is, what does it mean, and how it is connected with the concept of inertia and with the concept of force. We also looked at some examples of inertia of rest, motion, and direction. Our next step is to look at Newton's second law of motion and also look at interconnections, meaning how second law is connected to the first law. We will discuss that in the next video. Thank you.